Welcome everyone. Manuel Figueroa here, TCNJ, Department of Integrative STEM Education. I have with me Adam Kennard.
Hi, how you doing?
First year Technology and Engineering Education major. And he's here to tell us a little bit about his robot that competes in some combat robotic events.
Yes.
So who do you have here?
This is a plastic ant weight called the Captain. Ant weights, there are different classes throughout combat robotics. Ant weight is the 1 pound weight class. Very common, easiest class to get into. The plastic ant weight division, however, requires that everything about the robot is 3D printed, besides basic fasteners and all that. So any kind of spinning weapons, wedges, anything at all like that has to be 3D printed.
So these wedges that you made here, these are things you 3D printed?
Yes.
Okay.
3D printed, everything on the robot is PLA.
Okay.
There are multiple different materials allowed. Just can't do anything with like any carbon fiber integration, or TPU is also not allowed because of its flexible properties.
Okay. Okay. So why don't you give it a spin and tell us like the strategy of this robot? Why is this effective?
Okay. So let me just turn it on real quick. The strategy of this robot is basically to control the fight, put the fight on my terms, and be able to be very versatile.
Okay.
So when robots fight, it's typically 2-minute matches, and then if neither robot is knocked out by the end of the 2 minutes, it goes to a judge's decision. And the judges score the fight based on damage, control, and aggression. So this robot is designed to not necessarily do anything in the damage, but to be able to control the fight and be an aggressor in the fight.
Okay. And I've seen him move on the field. He accelerates very fast and gets to the opponent quick.
Yes, I have it's powered by a 11.1 volt lithium polymer battery.
Okay.
Which is a relatively big battery for the weight class.
Okay.
The usual voltage is 7.4, and it is 4-wheel drive. It is, and it's 4-motor drive, as opposed to some robots do 4-wheel drive, but only use 2 motors and use belts or some other form of locomotion. But this has 4 motors, 4 gearboxes, and each of them is attached to a wheel, which makes it just very powerful, and it has great traction as well.
Okay. Okay. How did he do in the competition?
Glad you asked. He actually just placed first place at First State robot fights in Newark, Delaware.
Nice.
It went 6-1, so 6 wins, 1 loss.
Okay.
It lost in the second round against a very tough spinner.
Okay.
Then it went down to the losers bracket and worked its way all the way back up and ended up beating the winners bracket robot in 2 fights in a row so that it could claim the championship.
Nice.
Yeah.
Good job.
Thank you.
Came back.
Yes.
He doesn't give up, huh?
No, not at all. Not at all.
Now, so you designed a lot of these parts here in our makerspace.
Yes.
Okay. Can you show us like what you designed here and how you printed it?
Yeah. So basically, again, with the whole control and aggression aspect, I wanted the front wedgelets to be interchangeable. So there are many different configurations, I would say, to be put on the front of the robot based on what you're fighting, because these wedgelets are very delicate, well, relatively delicate. But you don't want that when fighting up against any high energy kinetic spinners. Just doesn't end well for you. So what we do, this is the body right here.
So you drew this on shape.
Yes.
Okay.
Drew it on shape. learned it here at TCNJ. Before, I was very familiar with Inventor.
Okay, okay, so you did it on
Yes.
And so this is the housing where you put the power source
Yes.
and the sensors to connect with your
Motors.
your motors, right?
Speed
Okay.
controllers, receiver,
Okay.
battery, anything special in the robot, it's in there. It has, you can see it has the 4 different motor mounts.
Okay.
And then it is a little bit roomy for a robot. It can definitely be compressed in future iterations.
Okay.
And that's definitely something I would like to work on.
Okay.
It has more than enough space, which is both a blessing and a curse.
Yeah.
More weight, but not everything's crammed in, less of a chance of a short circuit or anything like that.
Okay.
But yeah, it's just very simple. I basically made a rectangle, extruded it, and hollowed it out in the basic shape that I wanted, and then went from there.
Okay. So then you 3D printed it.
Yep.
You know, something we have here is we have 3D printers that students can use for projects for class or like a competition like this. So here we have the Prusas and they're printing. They use PLA to print out whatever device, whatever part you need. Have you gotten to use some of these in your class?
Yes, I have. I used it in creative design.
Okay.
161 last year.
Okay.
And then I also used it in engineering design.
Okay.
I forget what that was last year.
Yeah. Okay.
Yeah.
Great. 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 Good. And then so you got to print your parts. And what's next? What's going to be for your next robot and the next competition?
Next robot, I'm actually working on a new version of a robot that I was able to cut the parts here with the water jet cutter at TCNJ in the metal shop factory.
Okay. Yeah.
There are some things. Overall, it did very well at the competition.
Right.
But there were definitely some hiccups.
Yeah.
Some design failures that didn't quite think of that when when I was designing that.
Yeah.
But
and I'm sure when you see your opponent, it makes you think of other things that you can do.
Of course. The weakest link always breaks. So eventually you just want to get rid of the weakest links and hope they don't find any.
Okay.
So that's what's in store. That's my next competition that I'm going to. Future iterations for the Captain.
Yeah.
I like all the attachments that I have right now. Currently, I have 3 attachments. I have the wedgelets that were presented just now.
Yeah.
I also have a huge scoop for any horizontal spinners that it just reflects. It reflects them right up.
Okay.
And then I also have a special wedge for any drum spinners, which is basically just picture a piece of pipe that spins upward.
Okay. Yeah.
I have a piece of, I just have a piece relatively skinny. It just goes right in, and again, it just puts the energy back on the other robot.
Okay. That's awesome.
Yeah. Yeah.
Great. Well, good luck.
Thank you
Good
very
luck on
much.
your next
Thank you very
competition.
much. Yeah.
Awesome.
It'll be a blast.
Yeah.